Welcome back to the Decode podcast here live at Apex 2025. And we're joined by Fraser Shaw with Watt Laser. And this is one I'm excited for because I make stencils, and Fraser's got a long and storied history in the stencil game, and specifically with laser technology. Previously with Tanlin and now with Watt, which is a young and innovative company that's really kind of shaking things up in the stencil manufacturing and quality assurance space. So without ado, Fraser, tell us a little bit about Watt. And I know all about it, but for our listeners' benefit.
No problem. Well, thanks for having me. First of all, I really appreciate it. I love what you guys are doing.
Oh, thank you.
It's really good, and you're shaking things up as well. I think that's really interesting that you're doing this. As some of you will know, I formed Watt like 5 years ago after exiting Tanlin, and we got involved with FCT with their nanoslick program. And we developed the new nanoslick program to improve the life of the nanoslick coating using lasers. And then we drifted into getting lasers to do more and more things, and we started getting the same laser to weld. The interesting thing about that process is that it uses a different laser from the one that most people use to weld.
Those welds are incredible. Yeah. Like the way they look, it's unbelievable. You get that level of detail and at that scale.
What was Elias's line? He said he feels like Tinkerbell Saturday.
I saw that. That was funny. That was funny. Yeah. So it uses what's called a nanosecond laser instead of a continuous wave laser that the normal laser cutting lasers are. So that was interesting that we used a different laser there. And then, of course, the same laser can mark as well and can do beautiful marking. So you can do really complex barcodes, lots of text. And one thing we found when we started working with stencils, especially around here, is that people love to put text on stencils. They love to put big arrows and logos.
Logos,
and
barcodes,
and like everything, like War and Peace on stencils. so this, the machine is really made for that kind of stuff. And the best thing about it is it's seamless as well. You can drive it with, you can use Gerber to drive this machine, so you can have it integrated with the rest of your manufacturing process really easily, or you can use JPEGs, you can use DXF, you can use whatever the hell you like, and you can drive it that way. So that was interesting to get that running as well, and that made it a really nice machine. So like the machine you have, Elias, is the kind of culmination of all those laser ideas into one system. The final piece being that we have CNC system that reads Gerber files, that can mark Gerber files, can weld Gerber files. Why not just make it inspect with Gerber files as well?
Why not?
So then we added a couple of cameras on there so that we can scan the stencil and take really detailed measurements. And that makes it a really rounded machine. It's kind of like the companion machine is how we describe it. You have your laser cutter, and LPKF and Tanlin make great laser cutters. They make great product, but the laser they use is for cutting. Clues in the name, is meant for cutting. The SE12 does everything else. It does the marking and the welding and the inspection all in the one machine. So that's how we got to where we are just now.
It's a brilliant platform, especially watching it inspect. I mean, it's revolutionized our inspection process. Like
the confidence it's giving you too.
Oh, absolutely, and the reporting that it produces, it's incredible. And then after the inspection to be certain everything's there that should be there and nothing's there that shouldn't, it then goes in and takes detailed actual measurements at various locations and spits that all out onto a beautiful inspection report. So it's really cool, and I think there are some other applications for this system that maybe you could talk about, and maybe something that CMs like yourselves may consider in the future.
Yeah, so part of the software suite for and we're talking now about the QC part of that machine. So we sell what's called the QC100, which is only inspection. So we started off making laser machines, and we're called Watt Laser, but we sell a machine that doesn't have a laser. So that's the QC100. And the idea behind the QC100 is to make it easy for stencil houses, first of all, to inspect stencils and make sure that what they're shipping is good. We then realized, hey, the guys who are assembling cards, they should be looking at their stencils too.
To verify
some
that
people
their supplier gave you the right thing, yeah?
Well, goods inward. We had a great call with a customer this week that just wanted goods inward. That's all they wanted. But we can do more than that. As a stencil wears, this machine can check how the stencil has changed over time. So it checks the size, the position, and the shape of an aperture. And it stores that in a database. And then it can check the next time you scan it, it will compare it with what it was before.
Wow.
And it's going to look for changes.
Wow.
Right? So if your stencil stretches in any way, it's going to show you how it's stretched.
What about the board itself? Can it do the same thing? Can you use it to measure to determine how well your board was fabbed according to the original?
Yeah. I mean, the software that is still in development. But for example, you could load up like a fiducial file from your board and then have it scan the board, and it'll tell you where the fiducials are on that board. And if it's stretched, it'll show you where it is.
Yeah.
And as an added bonus, if you ask it to, it will scale your Gerber to that measurement so that you can make the stencil to the card.
That's a cheat code.
I am really looking forward to that.
In placement, that's important too, actually.
Exactly.
So, I mean,
exactly.
Because we had this job, I got shipped in customer supplied parts, customer supplied stencil. It came in and it was a board. It was a big board, very thin board, and it was. Remember, like when I printed it, the middle was like dead set perfect, right? But then the far left was this way, and then the far right was this way, right? Like the stretch on it, and it was small components, so maybe I noticed it more. But when you're with the 01005 package,
you can't have it.
It's right, and
absolutely.
so I had to like measure with my gauges, and he's like, you can send, and I got to measure this, right? To have something automatically, that's insane.
Yeah. No, I mean that idea came from a few years back. I had an automotive customer in the UK. And that was their standard procedure was they would have us measure like 10 cards, find out how much it stretched.
Yeah.
And if it was a 5 micron stretch on average, they would have us stretch the data by 5 microns.
Right.
It was like tiny little movements, and they said, if you can do it, do it. Why would you not do that?
If you can have every single placement or every single aperture perfectly centered in the centroid data, I mean,
and that's the thing. If that data is created for a stencil, now you can then parse centroid data out of it for your pick and place.
Exactly.
Yeah.
And that was another thing too. I had to go through manually change all the pick and place, and then once I realized, because then I did the pick and place first, and then the printer, and then tried to print, and then after I did the print, I realized, we got a problem. And honestly, before that job, I didn't believe in PCB stretch. Because I come from a PCB fab house, right? Like, so I put it on my flying probe. If my needles are off by that much, it's going to affect whether it works or not. Yeah. I didn't realize that after reflow,
it's going to move.
It's going to move, right?
Exactly.
And that was the case with this one. They sent it to me assembled on the bottom side, and I was going to do the top side, right? And I didn't realize that after reflow, it can stretch like that. Because I was like, that wherever you're getting your boards from, sucks. If that's what they're sending you, stretched out boards, right? But there's other environmental factors that I never even thought of, because as a board house, you ship the product, it tested good, it's good, right? But you didn't realize there's other stuff after it that affects it, right? So
absolutely,
very cool.
Yeah, I definitely have been trying not to be too fanboyish of the Watt platform. I don't know if I did a good job.
I really appreciate it.
But
you have not. You've shown all of your cards.
Yeah, I mean that SC12 Pro is just it's something else. And
glad you like it.
And one thing I appreciate about Fraser and
this
Watt,
isn't just for show. He has dominated our group chats about this machine. He's been so excited about it.
It's been a slow build with him.
Yeah. The last thing I wanted to say is one thing I appreciate about Fraser and Watt is that. For those that don't know, Fraser has a history in stencil manufacturing. So having that unique perspective of like being in a stencil maker's mindset and understanding those challenges, you see it in the product. It's intuitive for somebody who makes stencils. So.
Problems and solutions. That's what this whole show's been about. And
well, I if you want to add it up, I'm 35 years making laser cut stencils. 35 years. It's like I really should be retired.
They haven't
I
been
am
around
so-
longer than that.
They haven't. I know. Yeah. So it's been a while, but the really interesting thing for me, the last thing I did before starting to make laser cut stencils is I studied computer integrated manufacturing, right, which was 1990.
Okay.
That far back, getting machines to talk to each other, and
Oh,
that's
wow.
kind of been a driver for me, like my whole career. Is as soon as I studied that, and that was to me that was the future 35 years ago. But what amazes me is that loads of people still aren't doing it 35
Right.
years later, and that's one of the things that drives Watt Laser. We want to give solutions to people, like have the machine use the same Gerber file that you use to drive your stencil cutter. That's going to
It just makes
generate
sense.
information, and that information you can feed forwards or backwards. You can feed it forward to your customer and say, look here, this is your stencil data. Here's the exact sizes of your apertures, right? They might be within tolerance, but maybe they're tiny little bit smaller. So you could feed that to your SPI and say, okay, your apertures are like they're 5 microns down, right? Still within tolerance, but you could use then that data on your SPI, and you would expect a tiny little bit less.
Yep.
And it would be measuring exactly, as you say, the position of everything. If you want to change that, you can feed that data forward to the pick and place and say, hey, here's some new data for you that's going to improve your accuracy. So for me, that's one of the things about Watt Laser is we want to solve problems, as you say. We want to, especially using data, to connect bits of equipment together and try and gather data, like on stencil life, how the stencil wears out, how the stencil moves over time, try and get people to use condition-based monitoring of their stencil. Because ultimately, people don't throw away stencils quick enough.
Yeah, sure.
And I always tell this story of one of my customers back in the day who said, well, how long does a stencil last? And when should we replace them? And I go, like, it depends.
Yeah.
It depends on a whole host of things.
Yeah. You sound just like Elias.
Well, he's answered the question as many times. It's like, what's the substrate?
I know.
What type of paste?
Yeah.
What squeegee pressure? What,
Exactly.
it's
Yeah, what's the print support like?
Yeah.
Yeah. And then this customer said, well, is 250,000 prints too many?
Yes.
And I was, of course it's too many. Are you crazy? It's too many. I throw it away, replace it.
Right.
It costs like $200.
Right.
Are you
I think
crazy?
you got your investment on
Yeah.
this one a while
you
back.
got it.
Yeah.
And this customer was doing like tire pressure monitors, right? They're tiny little things, and one stencil would make like 1,000 of them.
Wow.
So your cost per tire pressure monitor,
Fractions of a penny. Yeah.
and you're thinking, are you crazy?
Yeah.
But they said that it still works. I said, but there's bound to be some drop off in yield.
Sure.
There's bound to be something in there. So that's what we want to do with the QC100. We want to give people data so that they can make informed decisions, so that Elias can make more stencils.
Yeah.
Yeah.
Can
Yes.
sell more stencils.
Yeah.
I endorse this message.
But by doing that, you'd be helping your customer.
Absolutely. Yeah.
Yeah, and everybody wins.
Yeah.
Sure.
So it's not often you can say this is a win-win.
Right.
But this is a
Truly
win-win-win.
is.
Yeah.
Yeah.
I sell Elias a machine. He sells stencils. He sells, a service to his customers
Yeah.
that lets him sell more stencils. Everybody wins.
And your process wins.
Well, that's it. That's
Yeah.
it. Sounds
Yeah.
corny, but it's true.
It's true.
Absolutely true. Yeah.
Oh, this has been awesome. Great chatting with you, Fraser, and appreciate you taking some time to meet with us.
I
know
hope
you,
we can have you on the podcast at some point.
It's- Oh,
yes,
that's gonna happen.
I'm up for that.
Yeah.
I
Yeah.
love what you guys are doing.
Awesome.
Yeah, if he doesn't consent, I'll sick Elizabeth on
Yeah,
him.
There you go.
you don't want that.
All right, Fraser.
Thank
Thanks
you.
so much.
Thanks for talking to me.
You.
Cheers.